So I wanted to include a couple of examples of some things that Elster in particular is doing, and other vendors, of course, are also focused on how to build future-oriented and future-proof technology. So 2 examples just to give you an idea of the types of things that are starting to emerge and the types of things you need to be aware of if you're looking at how to leverage technology to embrace for the future. The REX Universal Metering Platform is a metering platform that's been released recently by Elster. And it was designed with an absolute future view in mind. All of the use cases were built around what all of the future use cases would be, not just from a device, but from an end-to-end solution perspective. And as a result, things that came out of that were a very modular radio architecture, right down to the hardware design, such that radio chips can be changed without forklift re-architect of the platform. IPv6 stack, the support of different types of protocol implementations around IPv6, also complying with the latest standard 802.15.4G. Again, standards aren't sufficient to ensure interoperability and future-proof, but they're a step in the right direction. OTA protocol changes, being able to change to protocols that don't exist yet even, being able to integrate tightly into this common board multiple different types of communications, WAN, NAN, HAN, and even more. And then upgraded memory and processors, because we don't know what the future holds, but we know we're going to need more space for the future. So whereas that was a device view, I've put in another example from a software architecture view. So EI Server is a platform that was designed by Elster, and today many don't even know this platform has the capabilities that it does, but it was built with an extremely modular approach that allows it to solve multiple purposes and to be adapted very, very quickly to a variety of uses. EI Server has, for example, around 400 installations, and these include the ability to act as a head end. If we implement it in one way, it can be implemented as a head end for AMI or advanced metering. In Europe, they call it AMM. It could also be for multi-vendor data collection, very similar to what you might see with some applications in the market today, where it can support many different protocols and where it can even do meter data management. It can be deployed in various different ways to meet various use cases and deployed very quickly. So it's adaptable, and adaptability and modularity is key to the future. And then ability to adapt to business processes, because utility business models will evolve and solutions are necessary that can evolve with those. And then back office integration flexibility, again supporting that utility business model evolution, looking at ways to reduce complexity and cost, and then being able to support a variety of different types of utility, for example, water, gas, and electric with a common platform. An example of that modular, flexible, multi-purpose approach to technology. So in closing, I'll comment on this. It is not the strongest of the species, nor necessarily the most intelligent that's going to make it through this transformation that we're going to go through in the coming decades. It is the utility and the other utility industry stakeholder that is most adaptable to change. That's the ones that are going to make it. And we have to collaboratively work together to find ways to be adaptable to change and to move through this if we will all collectively survive in the best way we can.
This is Jesse Burst of SmartGridNews, and we just heard from Ron Pate, head of the Solutions and Product Management for Elster's Electricity Business Unit. We're going to answer a few of your questions. Ron, we're running just a little bit late, but I've got some very interesting questions. Let's try to squeeze 3 of them in here if we can. Nicholas comments, it's a very interesting talk, but he asks if you agree that grid assets need to work more efficiently and that a key element of this will be storage, which could be seen as a replacement for generation and network assets. And he asked, do you agree this will need regulators to allow changes to utility business models? And he remarks that such changes seem slow in coming, or am I being unfair to regulators, he says. And several other people wrote in with similar questions like, how do I future-proof the regulators? Any thoughts there?
Yes, so I would say that the comments about what needs to happen with the grid asset is definitely something that needs to occur. And with regard to regulators, personally I believe, and I've dealt with various regulators over the years, I believe that one of the key things is education. We have to, as an industry, and this is utilities, consultants, technology vendors, need to find ways to help educate the regulators and help them understand the total environment and the technology in a way that they can make the appropriate decisions. So that's something that does need an ongoing continued focus in the industry.
Yoche asks, do you see a future where every appliance, residential, will have its own meter, eventually making the central smart meter not as important?
So I do see a growth in metering within appliances. I believe that in the various cases there will be different levels of metering in appliances. I don't necessarily think that every single appliance will ever have a meter. I don't know if a can opener will ever have a meter, but I do think the larger appliances will have meters, and it'll also be appliances tailored to the various consumers and what they can afford. So there is going to be an increase, maybe not every, but a large increase in that in the future, yes.
Brian asks if the Elster system supports open ADR and multi-speak and other protocols, and David asks if you're including LTE chips.
We are supporting multiple protocols, including multi-speak, for example, in our solutions. And if you look globally, we have different protocols that might be regionally specific. We are evaluating LTE. We've had numerous discussions with Qualcomm and other participants in the industry. We don't currently have that in the U.S. However, it is on the roadmap for our solutions as the market evolves. We are at 3G currently.
Terrific. Thanks, Ron. Now, next I'd like to bring up Kevin Cornish, who's the Operational Technology Practice Lead at Black & Veatch. And like Ron, he has over 2 decades of experience. And like Ron, he's worked with many different utilities in many different regions. And like Ron, he's a strategic thinker. He's someone utilities bring in for high-level advice, as well as help in project execution. So I know you're going to benefit from his perspectives. Kevin, thanks for stopping by.
Thank you very much. As Ron talked about, and I think we're all aware that there's, the future for utilities, we know it's going to be different. We don't know quite how. If we look backwards 10 or 20 years, I don't think any of us could realistically have envisioned where we are today. And that disruption is coming from a variety of areas. And I try not to duplicate what Ron talked about, but we'll touch on a lot of the similar themes, but from a slightly different perspective. I'm going to talk a little bit about maybe how internally utilities can adjust and face some of these challenges, as well as ways of integrating their solutions together in some different fashions. If we look at a couple key things that have impacted our industry, one has been the growth of distributed generation. This is both kind of traditional generation as well as, the recent significant expansion of renewables. And a lot of these are third parties, either customer-owned or we'll call them kind of merchants that are operating, small to medium solutions out in the distribution system. So this is where an enabling technology that didn't really come out of the utilities has had a profound impact on utility operations. The other is the growth in smart metering. Similarly, a new technology that's grown up from, advanced metering and kind of network metering, but this is one where the utilities consciously took enabling technologies, expanded on their capabilities, and deployed those both to reduce costs and to enable new customer service and efficiency of operations. And so we're going to be faced with opportunities in both of these veins. One is things that the market is bringing to the utilities that may be a bit out of our control. The other are how do we leverage enabling technologies to both meet those challenges as well as just use the technologies to do a better job of the core delivery of energy in the utility industry. So Ron covered a little bit of some of the impacts on the utility distribution system. One of the things that I guess I want to focus on a little is as we've had significantly more enabling technologies, and specifically around what I'll call advanced applications. If we look around the industry, the explosion of new, much more capable outage management systems, or the trend to distribution management systems as their maturity levels off. Replacement of first-generation GIS with much more capable solutions that enable a wide range of mobility of products. All of these things you could look at as single-point solutions that are delivering value. What makes the smart grid smart, the thing that utilities can really capitalize on, though, is the integration of these various solutions together. So the integration of smart metering into the outage management system, maybe it's an outage management module as part of a distribution management system that also integrates upward into the energy management system so that the distribution management is controlling distribution renewable assets and interfacing into the EMS that may be using weather data to do forecasting. But it's really the convergence of these different solutions together and the integration that is what takes us from individual point solutions in somewhat a siloed environment to the true strength that smart grid brings to the marketplace. At the other end of the equation is the customer. And really, this slide is touching on the fact that customers are completely different than they were 20 years ago. We had sophisticated industrial customers, large commercial customers that tended to have energy management philosophies, but most of us residential customers did not. In today's age, you can put in solar PV systems, small windmills, self-generation, and so customers have evolved from just being a purchaser of energy to perhaps a purchaser and supplier. And one of the issues facing the industry today is how to balance that. There's a lot of states across North America that are looking at the issue of net metering. How do you allow customers to participate in this change while at the same time, from an equity perspective, ensuring that the cross-subsidization is appropriate? I think there will always be some, but as more and more generation gets out there and utilities have to develop systems to enable and support the new renewables that they don't have control over necessarily, how do they do that and who bears the cost? And so this is a really important area, and it was touched on in one of the questions of engaging the regulators. This is, I guess I'll take a moment to comment on that also, is that I think this is an area where, like Ron said, awareness is key. Awareness not just of the issues, but this is probably an opportunity where utilities can really explain to regulators what their smart grid or overall enabling technology vision is, how the parts and pieces fit together. Perhaps it's a roadmap, a 10-year roadmap of how they look at using enabling technologies, the costs associated, the benefits, and then you can look at these different regulatory and kind of social questions from the perspective of what the utility really has at their disposal, what type of tools they have to address. This is just a slide to indicate, the variety of the, in this particular case, kind of the operational technology applications and solutions that are out there that we see in today's environment utilities grappling with applying. In some cases, they have these systems. In some cases, utilities are implementing them for the first time. They may be upgrading solutions that are no longer supported or somewhat obsolete. But again, the key here is that none of these systems operate in isolation, and they have to be looked at from an overall integrated approach. You absolutely have to have an enterprise-level operational technology roadmap or strategy, because in addition to not operating in isolation, they all depend on each other. So the interdependencies, the need to share data, the need to integrate these together means that utilities have to take a much larger, broader approach to implementing technologies than they have in the past.